So today I decided that I'm going to try and extend the point of the two pointers to see how that would look like if you're actually going to implement it in code. And I have the perfect example that I found here online. And the idea is you do a meeting planner that when given availability for slots A and B for two people, you need to be able to see if there's a time that matches between them. The key points to remember here is your A, looking at the slots that are available, right? So slot A versus slot B. The other key thing is that the slots are given as in time units of integers, so in epoch time, and so is the duration. So you can assume that 30 seconds, and the concept will work no matter what the time unit you're using, as long as it's integers. The other thing to remember is that these time slots are ordered. That's the only way two pointers will work. So in effect, what we are going to do is set the pointers at two places. So let's go ahead and start this work. So we'll call it something like def uh, meeting planner. So that's what we'll call it. It will take in slot A, and it will take in slot B. Slot A and slot B. It's actually gonna be. I'm just going to add this so that it's easier. So we're gonna take slot A and slot B. Now the next thing we want to do is put in two pointers. So we're going to have a pointer both for slot A and slot B. So I'm going to go ahead and introduce the pointers here. So let's say pointer 1 is that, and then initiate pointer, the second pointer as well. So what we want to make sure is we don't get to the end of the, we don't get to the end. We're gonna have pointer moving this like that. We're gonna have this pointer move like that. So what we want to make sure is we don't get to the end of it, and if we get to the end of any of them, then we need to exit. And if nothing is found, then we want to return a blank. So I can just start by doing that case. That's the easiest one. The next thing that I'll do is I'll implement a while loop. So I'd say while this is less than, remember we don't want it to get to the end, so it's less than slot A, and J is less than the length of slot B, right? We want to continue iterating, right? So we got in there. So the question is how how are we going to advance this? So we want to be doing checks, right? So we want to see if a slot is found between these two, then voila, we have found a match. We return that match, we are done. I think we just need to give the first match, and that's it. All right. But if however a match is not found, then we want to advance. So the question is, which pointer do we advance? Do you advance the pointer that is here? Maybe let's just do this. This was the pointer, right? So I'd have one pointer here, right? And then I'd have the other pointer here. Just gonna use pipe to illustrate my point. That's the next pointer here. So if there is no match, which one should we move? I think we can just imagine a scenario where maybe the next slot was something like 20 and 30. If the next slot was there because it's ordered, it would have appeared here. So what that means is we should move the pointer for the person whose slot has ended a bit earlier. That's what we want to do. So I'm going to go ahead and see how to do that. So I'd say in this case, if the slot, if at this current slot, at the current point, right, want to look at the second item. So if that is the smaller one, right, so if it's smaller than what slot B has, right, but slot B, the tracker for slot B is actually J. If it's smaller than that, then we want to advance slot B. So sorry, we actually want to advance this first one. So then I'm going to say that I is equal to I plus 1. basically advance by one step. All right, so I know this is going to work. In the other case, which is if it's equal or less, it kind of doesn't matter. The would still advance the J1. All right, you can even make this one a bit more concise as well. This is just a very simple addition. Normally I like to be a bit explicit with these items, but if it's this easy, then I'm kind of okay advancing it like that. All right, so this is great. So now we know that this is going to continue going through all these slots, but it will not stop if it finds it. So how do we know which slot makes the most sense? Well, again, we look at the easiest case. So what you want to do is, on the smaller item, we want to get the largest number of the slots that we are comparing. So that means I want to get the start point here. I want to get the start point, and the start point is going to be the maximum value of either the slot A at its, of course, at its index. Then I get 0, right? So I want to get the first item, and I want to check again for slots B. So let's see where slots B. Actually, you know what? So that the compiler can help me here, I'm going to set out this item. It's going to be true. The question itself, right? So I know that's slot A, and that's slots B, and yeah, we also need to take in duration. I'd forgotten to put in duration in the first problem. So you need to take that, and you need to take also the duration. All right. So now we want to make sure that that this duration is going to fit in between these two items. So I'd have the maximum of slots A, and so it's either that or whatever is currently in the slots for B. Again, I have to remember the tracker for B is J. The value we are taking is the first one. All right, so this will give us a nice place to start, and just want to get where it ends. So again, max, but now it's actually min, sorry, this time. And the reason for that is we want to check on this other side what's the least amount that we can get, so that we know that the viable period is between 10 and 15, right? So some big difference here. This is going to be what's the mean, and then the other thing is now I'm getting the last item. So now I'm getting this item, it's 50 and 15. All right, so we want to check if, right, the start value, right, or the end value, sorry, if the end value minus the start value, right, is equals or is less, this duration is greater than, or to be honest, equal to will also work, the duration that you have been given, then this is a success case, and you can actually return this particular pair, because that will be the first that we have found that works. So it will be, actually have to give the start time. So I think that was what they wanted. Let me see. All right, so they want to see the time that we can suggest, so that's okay. So you can give us a suggestion of the start and end it. All right, let's actually see if this guy will run. Right, so I think this code should work. Unfortunately, I have not set up the infrastructure to test it. Let me check. It was not closed. Anyway, so I think this is the general idea, and I think it should run. I'll probably check it before posting. But yeah, thanks, and yeah, that brings me to the end of it. Just to recap in terms of the complexity or the big O notation for this is that it's going to be an ON, and that's because if we look at the worst case scenario, we'll go through the larger item, say slot A, which has the largest one, and then we'll go all the way to the end and find nothing. So that's the worst case scenario. All right, thanks everyone. And yeah, let me know what you think. Let me know if there's a faster way to actually work through this problem, or if there's a way I could have explained it better. Thanks.